Students, now we are going to study one of the very important, interesting element of symmetry and actions or operations possible through or around it. And that element is called as improper axis of rotation. An operation that we can perform is rotoreflection. As various elements, we have studied identity, line means axis, plane, and point. But those elements could not give us all the possible permutable results of molecular arrangement. Therefore, it is a need to discuss this combo kind of the element. This element is a combination of line as well as plane. Accordingly will be the operations. If I have to define this element of symmetry, then it is a line or axis as well as a plane, and the alignment or position of the plane is perpendicular to the axis of rotation that we have chosen. See here, it is represented. And operation, if I have to say, then around axis what we do? Rotation. And through plane what can we do? Reflection. So it is a combined operation, rotation and reflection. It is represented by symbol Sn. N is the order of the improper axis of rotation. Let us observe the possible various results for different improper axes of rotations. Let us begin with improper axis having order 1, means S1 axis. The first operation possible on S1 means S11. What does it mean? C11 into sigma 1. I simplify it. S1 means order is 1. So axis order also will be the 1. And first operation around axis of order 1. And then reflection, first operation. So superfix that you are finding, no, that's a number of operation. And suffix whatever you are getting, that is order. So what is the meaning of C11? Identity. Sigma 1 means just a reflection. So after simplification, I will get S11 is equal to sigma, plane of symmetry. If I continue that S1 operation, means second time suppose if I perform the S1 operation, what does it mean? C1 2 times and sigma 2 times. C1 2 times means again identity, and sigma 2 times even is a number, so again identity. So result is identity. So S12 is equal to identity. So how many operations are possible here? Two operations are possible on S1 axis. Unique or not, I am not talking about that. Just the possibility till we reach to identity. Therefore, S1 operation is called as plane of symmetry. If we would have considered that plane of symmetry already, then S1 is not to consider. Repetition is to avoid. Let us find what S2 mean. If I take improper axis of order 2 and perform first operation, means S21, it means C2 operation one time and sigma operation one time. C2 operation one time is rotation by 180 degree and reflecting through a plane perpendicular to that C2 axis, and that is exactly equivalent to inversion. So S21 is equal to inversion, and S22 means C2 operation 2 times followed by sigma operation 2 times. C2 operation 2 times is rotation by 360 degree, identity. Sigma operation 2 times is even number by which we are performing reflection operation. It is identity. So result is identity. So S22 means identity. Since S21 is equal to I, we say S2 as a center of inversion. But center of inversion we already represent. It is a convention. If inversion remain present, we represent I. So S2 need not to represent. So if plane we have considered, then S1 we are not representing, which is a representation of that plane. If inversion already we have considered, means we consider all. It is a convention that inversion we consider. Then this S2 also not to represent. So in true sense, the application of improper axis of rotation starts from next order, that is third order. Let us see what about S3. See here, 6 operations are possible on S3 axis. Let us see one by one. S31 means C3 operation one time and sigma operation one time. If I simplify it further, then it will be C31 sigma. Such kind of operation we have not come across previously. It's a combo operation. It's a speciality of this improper axis of rotation. Next operation S32, it means C3 operation 2 times and sigma operation 2 times. Sigma operation 2 times means identity. So simplified result of S32 will be C32. If we have considered that C3 previously, then now we need not to consider this C32 or S32. Next operation S33 means C3 operation 3 times and sigma operation 3 times. C3 operation 3 times means what? Identity. And sigma operation 3 times means sigma. If we have considered sigma previously, then again not to consider. Means S33 not to consider if this sigma is previously considered. S34 means C3 operation 4 times followed by sigma operation 4 times. C3 operation 4 times means C3 operation 1 time. See whether you are getting it or not. C33 means identity, 360 rotation. Further one more time C3 operation means C34. It means C31. And sigma raised to 4 means identity. So simplified result of S34 is C31. And if we consider this C3 axis previously, here repetition not allowed. We need not to consider. Now pay attention to S35. S35 means C3 operation 5 times followed by sigma operation 5 times. C3 operation 5 times means C3 operation 2 times. And sigma operation 5 times means sigma operation. So it is a second combo pack operation we are getting, which is that S35. It's a speciality of improper axis of rotation, for which we need to consider this improper axis of rotation. Now S36 means C3 operation 6 time followed by sigma operation 6 time. C3 operation 6 time means again 360 plus 360 means 720-degree rotation. So it is identity. Sigma operation 6 time means identity. So result is what? Identity. So in general, if I have to say, S31 and S35 can be unique operation. But I want to bring your attention. How many operations are possible here? 6 operations are possible. If you see, the first operation is based on result of both. Means both axis and plane have a role. Second operation, major role is of axis. Third operation, major role is of plane. Fourth operation, major role is of axis. Fifth operation, both are playing the role. And sixth operation, that is equivalent to the identity. Here our cycle completes. Means what are you finding? Who is playing the major role? Axis is playing the major role. See here, for S4, 4 are the possible operations till we reach identity operation or result of identity. Let us see one by one. S41 means C4 operation one time followed by reflection operation one time. If I simplify that, what will the result? Same, C4 operation one time and then sigma operation. So it is a combo pack, unique operation, speciality of improper axis of rotation. Let us continue. S4 operation 2 times means C4 operation 2 times followed by sigma operation 2 times. Now C4 operation 2 times I can't simplify further, but sigma operation 2 times means identity. Means result of S42 is C42. But if we have considered that C4 axis previously, then now need not to consider this. So it may be the repetition. S4 operation 3 times means C4 operation 3 times followed by sigma operation 3 times. So what will be the result? C4 operation 3 times into sigma. It is also second combo pack operation that we achieved in this S4 improper axis of rotation. It is a speciality of the S4. Now last operation. S4 means C4 operation 4 times followed by sigma operation 4 times. C4 operation 4 times means identity. Sigma operation 4 times means identity. Identity into identity. It will be the identity. And identity generally, trivially, basically we consider at the beginning. So it also need not to consider. Means in general point of view. Two spatial operations may possible because of this S4 axis, and that is the need to discuss this improper axis of rotation. Which are the two unique operations may possible? S4 1 and S4 3. Just pay attention. How many operations are possible on S4 axis? 4 operations are possible in total. Let us recap to understand the actual nature of improper axis of rotation. When I consider S1, at that time 2 were the operations possible up to identity. For S2, again 2 were the possible operations. For S3, 6 were the possible operations. And for S4, 4 were the possible operations. Can you find something formula from these possible operations? Yes. If we consider odd is the order of the improper axis of rotation, then number of possible operations are double than the order. Means for S1, 2 were the possible operations. For S3, 6 were the possible operations. In case if I would have considered S5, 10 would have been the possible operations. For S7, 14 would have been the possible operations. What about the even ordered improper axis? Means for S2, 2, for S4, 4, means for S6, 6, for S8, maybe the 8. Sorry, if even is the order of the improper axis of rotation, then equal to order number possible operations will be there up to identity. Therefore, if you remember now, previously while discussing the identity, I consider it can be Sn or Sn2n. Sn if n is even and Sn2n if n is odd. I hope you are getting this point. Let us understand this improper axis of rotation by a particular example. I want to consider here trigonal bipyramidal PCl5 molecule. Now see the structure carefully. 3 chlorines are there in a triangle and one is above and one is below. Let me consider chlorine which is below as a chlorine 1 and chlorine above as chlorine 5. So a line passing through chlorine 5, phosphorus and chlorine 1 is our C3 axis. The same C3 axis can be the S3 axis. Means what I want to say, rotate the molecule by 120 degree around the S3 axis and then reflect through a plane which encompasses those trigonal 3 chlorines and phosphorus. Which plane it is? Right, horizontal plane. Then we will get new kinds of the operations. And we have discussed for S3, possibly S31 and S35, likewise two unique operations may be there. As a representative, now I show you how the rotation followed by reflection occurs in order to give the results of S3 operation. Now see here, first rotation by 120 degree. Now choose a plane which is perpendicular to the axis. This is a plane and now reflection started. The chlorine which was at the bottom, so chlorine 1 went up and chlorine 5 came down. As you are realizing the reflection for upper and lower chlorine, same case occurred there in other chlorines, means chlorine number 2, chlorine number 3, chlorine number 4, and forward the phosphorus. Their upper portion comes down and bottom portion goes what? Up. But for the sake of simplicity, only upper and lower chlorine is represented. In order you will get the idea what is this improper axis of rotation and what are the operations that we are saying rotoreflection operation. First rotation followed by reflection through a plane perpendicular to the axis chosen. Here it is a matter of chance that whatever the C3 axis is there, the same became the S3 axis. Here it is a matter of chance, whatever the horizontal plane is there, the same plane through which we are reflecting in this S3 axis operation. Let us see whether any improper axis of rotation possible for water molecule. See here structure. Yes, what do you think from this structure? Will there be the improper axis of rotation? If you remember, I told you S1, which is improper axis, is equal to reflection. So, are there any planes possible? Yes, two vertical planes are there. One is a molecular plane and other plane is perpendicular to the molecular plane. It means there is a possibility of improper axis of rotation. But what is the name of that axis? S1 means rotation by 360 degree and then reflection. Then which axis you need to choose? Choose axis which is perpendicular to the planes which are possible. Maybe molecular plane or maybe the plane perpendicular to the molecule. Just try. You will get the point. It means what? Either I have to represent it as a vertical plane or I have to represent as S1 means two S1 operations. Likewise I have to represent. But conventionally we represent plane, whatever it may be, vertical, horizontal or diagonal, in spite of S1 operation. So who has a right of representation? Plane has a right. So we will not consider S1. Wherever, whichever molecule may be there, if there is a plane of symmetry, S1 as an element of symmetry may possible, but we will not consider it in order to avoid repetition and in order to give the first right of plane of symmetry. Are you getting? So for other molecules, wherever plane will be there, I will not talk about S1. S1 is not to consider now because plane is considered. Now see other molecule, ammonia molecule. What do you think in this structure? Will there be any improper axis of rotation which can give unique operations which are not yet considered? No, such possibility is not here. So, in this molecule, we can say improper axis of rotation is not there. Let us see next molecule. It's a trans 1,2-dichloroethylene molecule. From this structure, you may think there is a possibility of S2 as improper axis of rotation. Absolutely. Suppose if you consider C2 axis as S2 axis and rotate the molecule by 180 degree, followed by reflection through a plane perpendicular to the axis or through a horizontal plane, what will you get? Yes, similar structure. Absolutely, it is right. But if you remember when I discussed S21 and S22 operation, especially S21 operation means what? Center of inversion. But conventionally, we represent center of inversion first. We give priority to center of inversion. In order not to have repetition, will we consider S21? No. Therefore, as was the case for S1, which gives the operation of reflection, we do not consider because reflection is our priority, plane is our priority. Likewise, S2 is equivalent to inversion, but inversion, center of symmetry, is our priority. Therefore, we will not consider S2 also. So higher order improper axis of rotation is our point of interest. So in this molecule, there is a no improper axis of rotation which can give unique operation which we have till now not considered. Okay, so let us see the next molecule. It's a BF3 molecule, planar molecule. Can you guess any improper axis of rotation here? Yes, as we discussed for PCl5 molecule, no. In the same way, here S3 as improper axis of rotation is present. Whatever C3 axis is there, no. The same C3 axis is the S3 axis. Now, question you will be with why should we consider that? Because S3 can give us two unique operations which we till now not considered. Which are those? S31 and S35. And other operations are there, but already we have considered. May result will be the identity, may result will be the plane. That already considered. May result will be the axis of rotation operation. Other than that, unique operations will be produced by S31 and S35. And for that, we need to consider this S3 as a improper axis of rotation. And two possible operations are there. So it is a one example where you can find improper axis of rotation. Unique operations you can get. Are you getting? Let us see next molecule. Here is a linear H2 molecule. And in this molecule, there is a no improper axis of rotation which can provide us unique operations other than usual operations, which are plane of symmetry or center of inversion or identity. Let us discuss last molecule. It's a linear HCl molecule. And here also there is a no chance to get any improper axis of rotation which can provide us unique operations, unique results. So we can say absence of improper axis of rotation. Now question you may be with, why the representation is by Sn notation? See, S stands for spigel, Greek word for mirror, and N stands for order of rotation. Means both things are involved in that representation. Reflection also is there signified by S, and N is order which signifies rotation, means axis. Now question you may be with, if rotation as well as reflection both things are involved in this roto-reflection operation, then why do we say it has a improper axis of rotation? Why do we give importance to the rotation more? See, you take one of the representative improper axis of rotation, say S3, and all possible operations you go through. It is true, both are involved in the operations, but you will find S33 means plane of symmetry is dominating. S32 and S34 axis of symmetry is dominating, and other where both are playing the equal role. So only one where plane of symmetry, other where axis of symmetry is there, and therefore the operation that we can do around the axis of symmetry, that is mentioned there, called as rotation, or we say element as axis of rotation. Other reason is reflection doesn't result variety of operations, but axis can give n minus 1 or large number of the various operations. And if we have to distinguish various improper axes of rotation, then order of the axis matters. Then who has order? Axis has order. Plane has no any kind of the order, because for plane only possibilities are reflection, and second reflection means identity. But for axis variations are there, and because of that, in order to distinguish the improper axis of rotations, order is to define, and order is for the axis. Therefore we say it is the axis of rotation. Yes, students. You may be with the question, why do we use the word improper? What improperness is present in these operations or element? See, you have studied proper axis of rotation. So throughout all operations, the element, the line remains undisturbed, the points remain unmoved. But in this rotoreflection operation, it is a combo operation. When we perform rotation, at that time line remains unmoved. I agree. But immediately after that, when we perform reflection, then the above point will come down point will go up, means they are disturbed. Only one point will be there, which is not disturbed. If we continue the operation, means second operation if we perform, then reflection doesn't give any kind of change because second time reflection means identity. So there remains axis of symmetry. When odd number of operation performs, then line doesn't remain particularly properly. But when even number of operations we do perform, then line remains. So properly, exactly every time line doesn't remain there. So, because of improperness, because of not observation of properness, we say it as improper. And I told you why we say as axis of rotation. So, name for the element we discuss and related operations is improper axis of rotation. Now, question you may be with, why do we consider this combo operation only for axis and plane? We can consider it for axis and inversion also, or we can consider plane and inversion also. In true sense, this axis and plane, the angle between them, exact decision we can what take. Suppose if I consider inversion and axis as a pair, then inversion is just a point. Then with respect to that point, how can I define the other axis of rotation? How can I choose that? Here what is happening? The axis perpendicular to that plane we are considering. So clear cut definition is there. Then somebody will say take any other axis. Will do. Yes, and what are the results are there after which can be obtained after rotation and inversion? Those can be obtained by rotation and deflection also and other symmetry operations. This improper axis of rotation or the rotoreflection, also called as rotoinversion, rotatory inversion operation, especially in case of the crystal lattices, crystal structures. So results are the same. What is our intention of this defining elements and finding operations? In order to get permuted possible combinations of arrangement. And all possible arrangements we can get by means of these five elements and respective operations. Which are those five elements? Number one, identity. Number two, proper axis of rotation. Number three, plane of symmetry. Number four, center of inversion. And this is last, that is improper axis of rotation. So all possibilities of arrangements we could able to define, we could able to find. Then what is the need of other operation? What is the need of other element? Therefore, we are not considering other kind of the combination. This is the only combination because of proper definition and because of getting maximum number of the unique operations. Overall, all unique operations we cannot cover. Therefore, this improper axis of rotation is considered. Are you getting? Yes, now homework of this session. Actually, in this discussion, I told you why don't we represent separately S1 and S2, but you have to mention in the comment box why do we not consider S1 and S2 as element or respective operations. And second work is you have to find out the possible improper axis of rotation in a methane molecule. It's one of the beautiful example to understand this improper axis of rotation. Actually visualize that. You have to mention the name of that improper axis of rotation which exists in methane molecule. Let us discuss how to represent these all operations, the general order of their representation in next part.